Hello and welcome to What, Why and How. In this series to understand PCA, the next topic that we need to understand is projections. Say we have an XY plane, the x-axis being represented by the basis vector 1, 0 and y-axis being represented by basis vector 0, 1. And in this two-dimensional space, we want to represent a house which has 3 rooms and is 4 years old. Assuming that x-axis represents the number of rooms and y-axis represents the age, then this house can be represented as a vector 3, 4. What this 3, 4 represents is that this particular vector is 3 units of magnitude in the x direction and is 4 units of magnitude, draw perpendicular to this, and is 4 units of magnitude in the y direction. And these two vectors 0, 3 and 0, 4 completely capture the information that is being represented by this vector 3, 4. These individual vectors 0, 3 and 0, 4 are nothing but projections of this vector 3, 4 onto the x-axis basis vector 1, 0, and 0, 4 is a projection of this 3, 4 vector into the y-axis basis vector 0, 1. You can think of projections like shadows. So if you have a light source coming from here, this 0, 3 is the shadow of this vector 3, 4 onto the 1, 0 vector. Now as you can notice, the projection of any vector onto the basis vectors of that coordinate system gives you the coordinates of the vector. Now in this case, the projection of my vector 3, 4 onto 1, 0 is 0, 3, which gives me my x coordinate. Similarly, my projection onto basis vector 0, 1 gives me my y coordinate. And these projections gives us the magnitude of this particular vector in the corresponding directions. These projections need not always be onto the basis vectors. We can have projection of one vector onto another vector. Say I have another vector p. Let's call this vector 3, 4 as b. Now I can figure out the projection of this vector b onto this vector p by simply drawing a perpendicular onto this vector p, and whatever new vector that I get, say k, this is the projection of vector b onto vector p. Like k is the projection of vector b onto vector p. So what does this k vector represent? Similar to how we saw earlier, when vector 3, 4 is projected onto vector 1, 0, the projection means how much of vector 3, 4 is in the direction of the vector 1, 0, right? Which is 3 units of magnitude in this case. Similarly, the projection of any vector b onto another vector p captures how much of vector b is in the direction of vector p. So the k here represents how much of information that is present in this vector b is captured in the direction of the vector p. As we go ahead further into these discussions and as we discuss PCA, the projections become very important. By performing projections, you will be easily able to figure out how much of information present in one vector can be explained by some other vector. Hope this gives you a clear picture of what projections mean. And as we discuss further, you'll understand more about the importance of projections. Thank you.